So this would be our first notes for Chapter 7 in Algebra. And we're going to start looking at exponents. And you've probably dealt with these before in your math that you've had before in middle school and earlier in high school. And we're going to define some terms here and see how to figure out the value of an exponent given different conditions. So the first thing we want to understand is you're going to see this term called a monomial. And mono means one, okay? And there's a couple ways we define this monomial. In the first one, it's an algebraic expression made up of one term. That's the one, mono. Okay, and I'll show you one here in a minute. It can be a constant, which means it's just a real number. It can be linear, which means it has an exponent that's equal to 1. And then it can be nonlinear with an exponent greater than 1. So here's some examples of monomials. And 2 is an example of a constant. 2x would be linear, and 2x squared would be nonlinear. Okay. So now, taking this idea of a monomial and looking at it, comparing it to exponents, we might have a monomial, x, and it could have a number in front of it, 2x. But then we have an x and an n. Okay. Whenever we see something like x with the letter n, that is called a power. Okay. And then n equals the number of times x is multiplied by itself. So if we had up here x to the third, that would give us x times x times x. And you probably know that. But then if we look at another example here, if we have 3 to the 4th, that means 3 times 3 times 3 times 3. That's 81. So let's look how we can do some of these exponents based on what we know, or what we're going to learn here in this one. And there's a few rules that we're going to use, and that is, the first one is called products of exponents, or powers. Okay? So when we have a situation where it's 2 to the second and we're multiplying, so this could be a dot, it could also be an x, but you're going to start seeing a dot, or even just little brackets with nothing between them. But we're talking multiplication. So when we have two monomials and we're multiplying them together and they have exponents, what we do is we add the exponents. So we have 2 to the second power, 2 to the fourth power, we multiply them together, we then add the exponents and we get 2 to the sixth. That's called products of exponents. And then we have products of powers. Okay, so here, a little bit different. We have 3x squared, which is a monomial. Then we're going to take that whole thing and we're going to take it to the 5th power. Okay, whenever you have that, you multiply exponents. Okay, and then we would have, this is actually a little bit wrong here, I'll show you in a minute, but we have x squared, so that would become 5 times 2, x to the 10th. But then we'd also have 3 times 3, so this would actually be 3 to the 5th times x to the 10th. And then we could just do 3 times 3 times 3 times 3 and figure out what that is, and then put it next to x to the 10th. But whenever we're doing that, we multiply exponents. And if we thought about 3, it actually has a 1 exponent. We just 1 times 5 gives us 5. Okay. And how we're going to use these products of exponents or powers in products of powers, we're going to use them to simplify expressions. And there's really 3 things we need to know when we're doing that. When we simplify an expression that has multiple numbers and constant and x's and y's, we're going to follow 3 rules. And they're going to be each base should appear once. So like if we have a condition where we have 3x squared y, we're going to multiply that by 2x to the 5th y. And see, we have an x here and an x here. In the final answer, we're going to have 1x and 1 y and 1 constant. Okay, so each base should appear only once. No powers of powers allowed. Okay, so we're not going to have like an x squared and then outside of that another power. Okay. And then also, if we have fractions, we're going to reduce all fractions. So let's kind of see what this will look like. We'll do a few examples here in a minute. So here's some examples. So we have this we start with, right? 3x y to the fourth, and then to the power of 2. So what we do is we take this 2, and we're going to take it to each thing, right? To the 3, to the x, and to the y. Right? We're going to do that. Okay, and that gives us 3 squared. It gives us x squared, and then it gives us y to the fourth squared. Okay. Then we take each one of those and simplify them. 3 squared is 9. X to the second power is x squared. And then y to the fourth is y to the eighth. So that gives us that answer. The reason this is squared is because we just do the powers. We're multiplying this power outside of this by the exponent that's inside, and that's x to the first, so 2 times 1 is x squared. Okay. And again here, we just simplified if there's no variable. So that's one example. If we look at another example, we have 1/2 a squared b squared to the third power, and then we have this negative 4b squared, that whole thing squared. So here's how we do that. We're going to look at these and just draw them out really quick. So 1/2 cubed, then we're going to have a squared to the third. We're going to have b squared to the third. We're going to do this inside thing here first. So then we're going to have negative 4b squared. Let's do that first. So negative 4 squared is going to be 16. Sorry about that announcement there. Just ignore that. And then we're going to have b squared, right? And then that whole thing is going to be squared, right? So then we keep going. So 1/2 to the third power. So this would be 1 times 1 times 1. That's going to be 1. 2 times 2 is 4. Times 2 is 8. That'd be 1/8. And then we have a squared. We're going to multiply these, right? A to the sixth. And then we're going to have these multiplied. B to the sixth. And we got all that done, right? And then we're going to do this thing here. 16 times, so 16 times b squared to the second power. So really we're going to have 16 to the second power. I'll leave that in here for a little bit. And then we're going to have b to the second power. It's going to be b to the fourth. We're going to keep going. So 1/2 a to the sixth, b to the sixth power. We'll leave that alone for a minute. 16 squared, so 16 times 16. Let me just do that really quick. 36, 3, 96, 6, 1, 6, 256 times b to the fourth. All right. Then we're going to do like terms. 256 over 1 times 1/8. And we'll just put that over here. 256 divided by 8 over, or times 1/8. We're going to end up with that. And then we're going to have, we're really multiplying these, so now we're going to add them, right? A to the sixth. Looks like we don't have anything over there. So a to the sixth. And then we're going to have b to the sixth times b to the fourth. That's going to be b to the 10th. And then we just need to do 256 divided by 8. It's going to go in 24 3 times. 16, that's 32. So that becomes 32 times a to the sixth, b to the 10th. So that's some examples of how to do these. And let me know if you have any questions. We will do a couple more practices in class. I'll even do some single problems that you can look at that won't take that long. Make sure you add these to your notebook.